Hi folks, in this video we're going to discuss direct serial communication between a Raspberry Pi and an Arduino. So we have a serial cable running from the Pi to the Arduino. If you want your Arduino to be remote, there's a version here that will show you how to use XB radios to do it. Here is the setup we'll have. We have our Raspberry Pi. This happens to be a Pi 4, but a 3 would work fine. I'm using a solid state drive. You're probably using a micro SD card for yours. That's why I have this set up. I have an Arduino. This happens to be a Metro, SparkFun sound detector, and a DHT11 temp sensor. The Arduino is capturing the data from these two devices, sending it over serial to the Raspberry Pi where we graph it. Now, I'm not doing any other analysis once the data gets here. You might want to analyze the sounds that are coming through and detect whether maybe a smoke detector is going off or something. Someone's knocking at the door. Whatever you're trying to detect is from the sound. Okay. Let's come back here. Now, the first thing we want to do is I'll clone the Raspberry Pi repo on the Pi. The sound detector, I'm just going to download it right here. So you can download that zip. Let me extract. Now you can right click, open with code, but with the Platform IO projects, it doesn't always seem to work properly. So I find it better if you have VS Code. Make sure you have Platform IO installed. If not, extensions, Platform IO. Then you'll have the Platform IO icon. You can choose Open. Open that project. Now, if we go to Platform INI, you'll notice in this case my board is a Metro, so you may have to modify this file a little bit. I'm using a Metro. I also have dependencies for the Adafruit Unified Sensor Library, the DHT Sensor Library, and ArduinoJSON. To get those, you choose Home, Libraries, and then search for the two libraries. If you go DHT, I think if you just download the DHT or install the DHT sensor library, it brings in the Unified Sensor Library also. You'll find out when you compile. And then also ArduinoJSON, and that's this one right here. That's only because I'm sending my serial data as a JSON packet. If you just want to do a serial.write, you could avoid this altogether. But it makes the packet nice and clean that we're sending, and we'll look at that in a second. Now, one other thing I need to do, I have a pup hollering at somebody in the background. One other thing you may need to do, depending on the board that you're using, I had to actually get the drivers. I had to get the drivers for the Metro on my PC, which were these drivers right here. So if you happen to be using a Metro and you don't have the Arduino IDE installed, you'll probably have to go and grab the drivers. If you just have a regular Uno or something, probably not. Okay, that's it. Let's take a look. There's only a single file here, which is main.cpp. Our connection. Let's go. Oh, right here. Here's our connection. It's pretty straightforward, not so bad. The sound detector, we have the envelope pin to A0, 5 volt and ground. With the temp sensor, we have the out pin, which is the pin in the middle, over to pin 2 on the Arduino. Also have a 10k ohm resistor between out and 5 volts. You don't need that, so if you don't happen to have one, just leave it out and you can run your 5 volt right to your plus pin on your sensor. You might also have a 4-pin sensor, so you might have to look that up a little bit. Okay. So that's what's happening up here. This is just so I can have a timer so we don't block our loop. If you come down here, what you're going to notice, I'm going to check the interval to see if a second has passed, and that just avoids having to put a delay down here of. Oh, let's just do it twice. A delay down here of something like a second or whatever you want your delay to be. The problem with using a delay is it's going to block your I/O, so everything's going to stop at this point. This way, if you just check to see if a second has passed, if it hasn't, any other code you have down here would still run. Right? All we do is we check to see if a second has passed. We grab the temp and the sound. Up here, you'll notice we build a JSON document object called doc. We capture the sound, we capture the temp. Inside of doc, we create a property called sound with the value sound, a property called temp with the value temp. We do a serialized JSON. We pass the doc and the serial port that we want to write to as an argument. If I use, there's a serial JSON pretty function. That one works fine. Again, these are functions inside of the library that you downloaded for ArduinoJSON. We can see that. Let's load this up. So I'll first just do a quick check. My Arduino is attached to my Raspberry Pi, so what I need to do is I need to attach it to my PC here. And now that we do that, we should be able to upload. If we open up a SerialPort, serial monitor, we can see that data coming through. And it's coming through in pretty format. Now again, I didn't want to waste all the extra spaces and line returns and such. I just wanted to use this version of it, and it's coming. So now what you're going to see is it's printing line by line, right? So it prints and then prints a clean line. And on the other end, it was just nice and easy to get that. Not necessary. You could play with how you parse out the data on the Raspberry Pi side, but this just made life a little bit easier. Okay, so that's it here, right? Nice and simple. Data's coming through. I'm going to pull. Just going to disconnect here. Let's switch over to that. So all I did was I disconnected from my PC, and I'm going to just connect right here over to my Pi. Let's make that a little bit cleaner. So now I'm running directly to my Pi, and that serial data is going to be sent to the Pi, and we want to capture it over here now. Okay, so what do we need to do? Well, we need to first get onto our Pi. You might have a desktop for your Pi set up with a monitor and keyboard and such. I do not in this case. I'm going to SSH in. So 192.168.1.174, I think. Yep. Okay. And here, let me do this. I don't know if you can. It might be. Probably would help if I transitioned over to. Folks, all I did was just opened up. Yeah, might as well just do it again. All I did was just opened up PuTTY. If you're on a Mac, you really don't need it on a PC either. But I've just used PuTTY for so long, I'm kind of stuck using it. But you can use a terminal on your Mac or even a terminal on your PC. The other thing I want to do is I'm going to go to Appearance, just Window, and change the font size. That way, as I drag that a little bit, you'll be able to see it better. So we need to clone this here now. Let's grab the Raspberry Pi code, and we'll copy that. Perfect. Now I'm not going to, let's just run it. I guess we've come this far. So let's do, I have Node all installed. I have Node all installed. How you get Node on your Pi is up to you. I like Node source. So if you take a look at Node source, go to their Git Repo, scroll down, you can run that line at the terminal first. Once that runs, you could run that line. This is the case of the Raspberry Pi operating system. All right, let's come back here. Let's change ls. We have our app, and then we have public. And what I'll do is I'll open this up on my PC in VS Code in a second. Let's npm install, and we're going to install the dependencies. We need Express, we need SerialPort, and we need Socket.io. So those are the 3 dependencies we'll need for the project. Shouldn't take too long. Cool. And now we can npm start or just node app.js. Perfect. Listening on port 3000. Let's check this out. So 192.168. Where are we at? 168.1.1. Was it 7.4? I think so. Here we go. And our sound starts to go through, and you could just see as soon as I started to talk, the sound spiked up a little bit. And we'll let that run as I talk about the code, and then we come back to it. 3 files. App.js, here's our server. Inside of public, our front end, we have index.html, and the logic is index.js. Inside of index.html, we have a couple of scripts, one for Plotly, one for Socket.io, one for our logic, which is index.js. We have a single div, and that's for our sound chart. You could call this whatever you want. I just called it sound chart. Let's look inside of app. We're serving up an Express server. Express is going to serve up our index.html file. We're using Socket.io, and that's giving us real-time communication between our back-end app.js and our front-end index.html and index.js. These are the 2 files for our front end. My SerialPort connection is at USB 0. After you plug your Arduino into your Pi, you might want to check it. You can check it with that line. At the end of the list, you'll see a port that your Arduino is connected to. Odds are pretty good that this will be the one. Here's where you could put in a delimiter for the data that comes through. Again, it was easier for me just to send through that separate line, so I'm just getting lines of data that come through. And the important part is really here. Not that it's not all important, but here's the line right here. So we have our parser. We built our parser object, and it's listening for a data event. What's coming through in the data event? Well, that data from the Arduino. Right? So we're listening for that. That's that JSON object, JSON string that's coming through from the Arduino. We have a variable name. We just call it data here. You could call it anything you want. And then what we do is we use Socket.io to emit our own event. I called it state data, and the packet is going to be that serial, that JSON string that we got via serial data, but we're parsing it to a JSON object. And then what happens is we're going to listen for state data on the front end. So in the back end, we're emitting to that event. What is it? Well, it's going to be that JSON object with the temp and the sound. On the back end, inside of index.js, and we just load up that file right here in index.html. We also have socket.on, and we're listening for that event. So inside of data, we're going to get that object, that JSON object. Plotly.extend traces, it does just that. It's extending that chart for us. And as we look at this, this is why This is why this chart keeps moving. So every time new data comes into that event, we extend this chart. Let's come back here. You don't need the code here to slide. You could get rid of all of this and it would work just fine. Check out this is basically boilerplate code from the Plotly website. So check it out on Plotly. We build just a function down here to grab the current time, so I can put the time on the along the x-axis, and then along the y-axis I'm putting the data. Again, you could you could do this with temp, because we also have that temp property inside of data too. So maybe you want a second chart, or maybe you want 2 lines on the same chart. Well, you could do that by building a temp object and then adding that here, comma temp, and it would work just fine. That should do it, or at least I hope that makes it a little bit clearer, than it was. It wasn't a very loud knock. There we go. It's a better, and you can see those spikes as I knocked as we go. I guess the other thing I should do quickly is this. If you want to do something else with that data instead of just plotting it, let's add scope here. And now what you can do is you can do whatever you want. So maybe you have a module to store data. In a database, maybe you have a module and you're looking for something, right? So you're analyzing, you're looking for a certain spike in the data for a certain number of seconds, and maybe it's for, a smoke detector or something like that. Maybe you want to send a text in that case. Maybe a push notification. Whatever it is you're trying to do, I'm just graphing it out here just to kind of complete the process of getting it from the Arduino to the server and then to the front end. All right, I hope it was helpful.